Everyone. Today we're going to be talking about adding and subtracting radicals. So open up to this page of your notes. I believe it is page, sorry, I should have known this already, page 15, and copy along with me. So the biggest thing we need to know about adding and subtracting radicals, and this is different from multiplying and dividing, is that you can only combine what we call like radicals. Like radicals have the same index, but also, this is really important, the same radicand. So not only do they need to have the same type of radical symbol, but also what's inside the radical has to be exactly the same. So what we're going to do is we're going to simplify everything first. So whatever radical we have, we're going to simplify everything first. And then we're going to combine like radicals by adding the coefficients. And keeping the same radical. So this should say coefficients here. And for some reason it's not clicking. And this one should say radical. So coefficients and radical. So let's take a look at some examples. All right, so in example 1, we have 2 times the square root of 45 minus 2 times the square root of 5. So the very first thing is we're going to simplify our square root of 45. Square root of 5 is already simplified. 5 is prime. So when we prime factorize 45, we get 3 times 3 times 5. And of course, our pair of 3's can get kicked out. So we get 2 times 3 times the square root of 5. And then we multiply, and the 2 times 3 gives us 6 times the square root of 5 minus 2 times the square root of 5. So we have exactly the same radical and index and the same radicand. Because of that, we can combine them by adding or subtracting our coefficients. So that's how we got 4, and keeping the radical exactly the same. In the second example, we have negative 3 times the square root of 12 plus 3 times the square root of 3 plus 3 times the square root of 20. Again, simplify everything first and kick out any pairs. Multiply our coefficients, and then look for like radicals, radicals that have the same index and the same radicand. Now this one is a 6 square root of 5, and even though it has the same index, it does not have the same radicand, so it is unlike, and because it doesn't have anything with the same radicand, it can't be combined with anything, it just comes straight down. Then the other two, because they have the same radical and radicand, we can combine their coefficients. Negative 6 plus 3 gives us negative 3, and we keep our radical the same. So that's how we're going to do all of these problems. So now what I'd like for you guys to do is to flip to pages 16 and 17, and we're going to fill in the final column that says adding and subtracting square roots. So this is number 1. We have 13 times the square root of 5 minus 7 times the square root of 5 plus 11 times the square root of 5. All of these are like radicals, so we just have to combine our coefficients and keep our radical the same. So 13 minus 7 gives us 6. 6 plus 11 is 17. The square root of 5 stays the same. Number 2, we have 4 times the square root of 3 plus 2 times the square root of 75. So we don't have to simplify this one. That's already prime factorized. There's nothing else that can be done. The 75 can be broken into 3 times 5 times 5. The pair of 5's gets kicked out. So this becomes 10 in front here, and 3 stays inside the radical. So now, even though it didn't look like we had matching radicands, we actually do. So all we have to do, they can be combined, all we have to do is keep our radical the same and add our coefficients. So we get 14 times the square root of 3. Okay. In number 3, We have 5 times the square root of 3 plus 4 times the square root of 48 minus 2 times the square root of 32. Again, nothing matches at first, but if we simplify, we can see that this 48 is going to simplify to have a radicand of 3, which is going to match our 5 times the square root of 3. So these are going to end up being able to be combined. Once I multiply my coefficients, I get 16, and then I combine my coefficients to get 21. My radical stays the same. This one, because it has a 2 inside, is unlike the others, so it just comes straight down. So this one was like the second example that we did in the notes. Okay. Number 4 has 4 different radicals, so this is kind of a pain. It's getting to be a lot of work, a lot of simplifying, but we know how to do this. We just need to be patient, go through our steps. So we end up with a 2 in front here, a 3 times 3 here, and then our minus 3 is being multiplied by a 2 and a 3 here. Okay. So then when we simplify further, we end up with 7 times the square root of 6 minus 2 times the square root of 3 plus 9 times the square root of 6 minus 18 times the square root of 3. So we have 2 different types of radicals. We have a square root of 6 and a square root of 3. Both of them can be combined with the other square root of 6 and the other square root of 3. So when we combine our coefficients that match with the matching radicands, we get 16 times the square root of 6 minus 20 times the square root of 3. Okay, and finally, the last one, number 5. Again, there's a lot of work to be done, but we'll do it one step at a time. 300 gets broken down into 2 times 2 times 3 times 5 times 5. Again, make sure, especially when you're dealing with these large radicals, that you multiply your numbers out to make sure that you get what you started with. 50 simplifies to 2 times 5 times 5, or factorizes to that, sorry, and 32 factors to 2 times 2 times 2 times 2 times 2. Kick out your pairs, multiply your coefficients. You end up with 7 times the square root of 3 plus 100 times the square root of 3 minus 25 times the square root of 2 plus 28 times the square root of 2, and combine your like radicals. 7 plus 100 gives me 107 times the square root of 3, and negative 25 plus 28 gives me positive 3 times the square root of 2. So now what you guys are going to do is try some practice that Mr. Manuel is going to give you.